Right, hello. In this video, what we're going to do is we're going to look at two past paper questions from the waves topic at Nat 5. So we'll go through these two questions in detail, showing all the working, and then you can have a go at some yourselves. So, this first question. A pupil is sent exam results by a text message. The frequency of a signal received by the phone is 1900 megahertz. The phone receives radio waves. What is the speed of radio waves is part A. Then part B, calculate the wavelength of the signal. Part C, the pupil sends a video from the phone. The message is sent by microwaves. If the message travels 72,000 kilometers, calculate the time it takes. So, our first question, what is the speed of radio waves? This would just be worth 1 mark. And A, this is something we just need to know. The speed of radio waves, remember, radio waves are part of the EM spectrum, which means they're a type of light. So the speed of radio waves is 3 times 10 to the power of 8 meters per second. Or you can write that as 3 times 10 to the 8 ms to the minus 1. Doesn't matter which one of these you use, as long as you get the 3 times 10 to the 8 bit right, and you do need units. B. Calculate the wavelength of a signal. So this is a standard wave equation question, and what we're going to do is what we always do for a question in physics, write down what we know and what we're trying to find out first. So we're trying to find out the wavelength. So we don't know that, let's put a question mark. We know the speed, because we've answered that in part A. The speed is 3 times 10 to the 8. And we also know the frequency, because it tells us up here that the frequency is 1900 megahertz. So 1900 megahertz. And this brings us to the next bit we need to remember. We need to remember what mega means. So mega means times 10 to the power of 6. So this actually means 1900 times 10 to the power of 6 hertz. And if we've got these three things, then we know what equation to use. We just look for the equation that has wavelength, speed, and frequency in. And that is the wave equation, V equals F lambda. We want to rearrange this though, because we're trying to work out lambda. So if we had this as a little triangle, it would look like this. And we're trying to work out lambda, so that's to tell us it's going to be the speed divided by the frequency. So we've already got a mark here for writing down this equation, but then we're going to rearrange it. Lambda equals V over F, and we're going to substitute in these numbers. So we'll put 3 times 10 to the 8, and we'll put 1900 times 10 to the 6. Now we need to be careful when we do this on the calculator. So we're going to do it in brackets just to be extra careful. So we've got 3, then we'll press in times 10 to the power of 8, then divided by, we'll put the bottom bit in brackets as well, 1900 exp again, times 10 to the power of 6 this time, press equals, that gives us an answer, that is a decimal, so we'll press this to get it as a nice rounded, sorry, it was a fraction before, we'll press this to get it as a decimal. That's giving us a wavelength of 0.15789. But remember, we don't want all these numbers, okay? Standard in physics is to go to 3 significant figures. So if we do that, that's going to be, here is our significant figure. We look at this one, this is more than 5, so this is going to go up. So our wavelength then is going to be 0.158 meters. And we'll just underline this to make it extra clear that this is our answer for the wavelength. Now, I haven't left myself much room. I don't want to turn it over. So let's box that off. And then now, part C. The pupil sends a video from the phone. The message is sent by microwaves. Okay, we know the speed of microwaves. Okay, We know what frequency the microwaves travel at. If a message travels 72,000 kilometres, calculate the time it takes. So once again, our standard start, write down what we know and what we're after. We're trying to find out a time. We know a distance, 72,000 kilometres. We know a speed. Remember, because they're microwaves, so we know the speed is 3 times 10 to the 8. And we also know a frequency. We know the frequency of the microwaves is 1,900 megahertz. So what we want to do is look through our equation sheet to find an equation that has all of these things in. And the equation that has them all is distance equals speed times time. Okay, because we've got a distance, we've got a speed, we're trying to work out a time. So again, if this was in a triangle, this would look like this. Trying to rearrange this for time, so we cover that up, we've got distance divided by speed. And that's us, we've already got a mark for writing down the correct equation. So time equals distance over speed. We need to again be careful here. Our distance here is in kilometres. Remember, in physics, the standard units for distance are metres, so we need to change this. And if we remember our prefixes, kilometres means times 10 to the 3. So our distance is actually 72,000 times 10 to the 3. Our speed is 3 times 10 to the 8. And again, we just pop that into our calculator. So, going to be careful. We've got 72,000 times 10 to the 3. That's going to give us the kilometres bit. We're going to divide that by 3 times 10 to the 8. Going to press our SD button again because we don't really want fractions in physics. That's going to give us an answer of 0.24 seconds. Now we don't need to do any rounding to that. That's already a nice small number, so we don't need to worry about significant figures or anything there. So that's used your wave equation, and it's used your speed, distance, time equation, and it's used the fact that you know that all light travels at this speed. So that's sort of put a lot of the stuff we've done together into one question. And that's generally how the past papers go, okay? There can be several parts to each question, and it's going to require you to use multiple equations from the same unit. Okay, now, we're going to look at one more past paper question, also from the waves topic. So, in this question, a ship is carrying out a survey of the seabed using ultrasound waves. The transmitted waves have a frequency of 30 kilohertz. Part A, what is the speed of ultrasound waves in water? Part B, one pulse of ultrasound is received back at the ship 0.36 seconds after being transmitted. How deep is the sea bed? So, A, what is the speed of ultrasound waves in water? Ultrasound waves, that's just sound. Now, you probably know already that the speed of sound in air is 340 meters per second. You probably won't know the speed of sound in water off the top of your head, and you don't need to. It is on your data sheet. So if you look on your data sheet, there is a table, normally at the top right, but that could change, that gives the speed of sound in different materials. And one of those will say the speed of sound in water. And we need to know that ultrasound... we need to know that ultrasound is just sound. So if we look on our data sheet, it will tell us that the speed of ultrasound waves in water is 1,500 meters per second. Again, we could have written ms to the minus 1 there. It's up to you which one you do. I'll generally use this one just because that's what I was taught. But either works, so you'll see me swap about just so you're comfortable with both. Now, part B. One pulse of ultrasound is received back at the ship 0.36 seconds after being transmitted. How deep is the sea bed? Now, when you see this question in the exam, generally for this type of question, there's going to be a little image, and there was for this one. So I'll just draw a very bad ship now. Okay, on the water. Okay, lots of you will know that's a terrible drawing of a ship, but it will serve its purpose here. Then this is the sea bed. So what's happening is this ship is sending out a signal. It's coming down here, bouncing off the seabed, and then coming back to be received by the ship. The time it took for that signal to start here, come down, and bounce back up was 0.36 seconds. We want to figure out how deep it is. So we're trying to figure out this distance here. And that is a distance, because it's the distance between the ship and the bottom of the sea. So let's write down what we have and what we're after. We're trying to find a distance. So let's pop that down. We know we're speed. Speed is 1,500. Now, we know the time. We know that it takes 0.36 seconds for the signal to come from here, go down there, and go back up. But we only care about this distance. We don't care about the distance down and back up. So we only care about the time it takes to go down. And that's going to be half of the time, isn't it? Because it's going to come down and then it's going to spend the rest of the time going back up. So our time is actually going to be 0.36 divided by 2, which is 0.18. And again, we look for an equation that has these in. That equation is distance equals speed times time. If we did a little triangle again, we could do this if we wanted to rearrange it, but you'll see that the equation's already the right way round for working out distance. So that's going to be v times t. Sub in our numbers, we're going to put in 1,500. Now for our time, be careful we put in the 0.18 seconds. Okay, that's us got 2 marks now for this question. Actually, that's us actually probably got 3 marks by now. We would have got a mark for realising that the time needs to be halved, a mark for the right equation, a mark for subbing in, and then if we pop it into the calculator, do 1,500 times 0.18, then that gives us an answer of 270 metres. And then we'd get a final mark for having the correct answer with units. Okay, remember, units are super important. What I didn't do up here actually, make sure your answer is very obvious. You can't assume anything with the marker. Make it as clear as possible. Okay, so that's us gone through 2 past paper questions. Hopefully that's a nice wee reminder of how you use these wave equations and you'll be able to tackle some yourself. So thanks again for listening.